Hello, this is Jason Andrews,
This is Dennis Godwin.
and this is our presentation on our paper, which explores the relationship between ground moisture, vegetation cover, precipitation, and severe fire events in Northern California. DWI and NDVI are uh, indices that are commonly used to assess the health of forests, especially in the context of fire ecology. They can be very useful, and a lot of papers have found links between lower measures of NDVI or NDWI and um, major fire events. So our project looks at two fires that occurred in 2021 and the landscape measures preceding the fire. So our study gets at three essential questions, all of which are very much interrelated. Essentially, what we were curious is if we could measure any kind of discernible trend in NDVI or NDWI in the land that would burn in 2021 during the years preceding each of the two fires that we look at. Did vegetation cover change, and what factors might have led to these changes if they occurred?
Imagery for this project, we sourced Landsat 5 and Landsat 8 imagery using Google Earth Engine as a medium. We used data for Landsat 5 from 2011 with Level 2 Collection 2 Tier 1 data. And then in Landsat 8, we used 2013 to 2022 with the same type of data from the Landsat 8 data archive. We skipped 2012 because there was no quality data during this year. The only Landsat that was active was Landsat 7, and it has the graphical issue that causes the images from it to not be useful for our analysis. In order to analyze the relationship between the chosen indices and 2021 fire incidents, the first step was to create a collection of satellite imagery, which we used the Landsat 8 collection, the Landsat 5 collection in order to create. We filtered them by the correct dates and then applied the correct cloud masking functions to each of them, and then added the NDVI, NDWI, and NBR using the normalized difference function in Google Earth Engine, and then reduced this collection using median by year to create median indices for June and July of every year. So at the end, we had median reflectances and indices for these summer months for each year in the data set, which ended up being 21 years of single images. We chose to use June and July for the dates of analysis because the fires occurred on July 31st, 2021. So we wanted to know mostly about the indices in the 2 months leading up to those fires. We thought that the indices for the entire year round might not have as much of an effect on severity of fires as the ones leading right up to it. So we then pulled all of the relevant bands from this image collection, created GIFs, and extracted the mean data from each of the fire polygons, and then divided up the frames using Photoshop to make individual maps of each measure for each year. And those were our final products for the analysis. As we can see from this animation, NDWI appears to sharply increase suddenly in 2008, which was the first strange thing that we noticed about this data set. Uh, the sort of pattern of the NDWI in the southern half of the image in 2008 doesn't look like landscape texture. It looks more like a cloud or some gradient that's put over the image itself. So we can already tell that something happened in 2008 that stands out from the other years. And we can also see that NDWI is very low in this region in general, especially in the study areas. It is on the lower end of that range, which says that this is a fairly arid region, but there isn't any sort of long-term visible change in NDWI between the start and the end of the study period.
So the true color composite is useful for visualization for a couple of reasons. One is that in 2008, you can very clearly see smoke getting picked up by the sensors, which does render some of the data for that year difficult to use. You can also see that the overall landscape is kind of evolving in patchworks of different smaller fires over the 2 decades of the study period, um, rather than a general landscape level trend of any measure like NDVI or NDWI. And then finally, at the end of this, you can see the fire scars from the 2021 fires um, in the year 2022.
So in the false color composite, we observe the same regional trends of patchworks of fires that happen and then recover fairly quickly and then happen again in different regions rather than a broad change over the entire landscape. We also see very clearly the interference in 2008. Especially in this image, it's very clear that the reflectances suddenly become very anomalous from the previous year. Uh, and this is consistent in these wavelength ranges with Mies scattering, which also makes sense given that we know that there is a lot of fires that happen here that could very well be forest fire smoke, and that would account for the anomalous results in 2008.
So a couple of things to discern from the NDVI visualization here. One is, again, at the landscape level, not a very noticeable trend, except for the fires that do occur throughout the 20-year period we're looking at. But then you do see it bounce back pretty quickly. It only takes a year or two for it to get back to that dark green color. Honestly, in this GIF, the most interesting part to look at might be Trinity Light there to the east of the fire zones.
Patterns that we've been talking about in the other indices are even clearer in the NVR animation. We can observe fires overlapping the fire zones in multiple years, most prevalently in 2008 and 2009. You can tell that both the river complex and the monument fire zones experienced large burns in these years and then had no major burns for about the next decade or so. And this shows that instead of NDWI being a broad regional trend, you can tell that the main driver of these fires was the lack of burns in the decade leading up to them between the 2008 fires and the 2021 fires.
So given the trends that we did observe with NDVI, NDWI, and NBR, um, we were curious to see if it did correlate with drought, which has been a real factor in Northern Californian fire ecology. Um, and so at first blush, this chart does make it seem as though NDVI takes a dip following a couple of relatively low precipitation years, but it's not quite so straightforward. Simple linear regression shows that the correlation between NDVI and um, precipitation is almost non-existent. And what we were seeing in the previous graph, the blip there really did just have to do with a large portion of the landscape burning that year. So just some concluding questions and reflections here. So we were on some level expecting to see kind of a long-term downward trend in NDWI and NDVI leading up to the fire. We were expecting kind of a drought condition forest, state of the forest to become evident. Um, we don't really see that in the data that we collected in the scope of this study. Um, the main factor in all of these, in answering any of these questions here, is really just how often the landscape is burning and how large those fires are to influence the overall characteristic of the land. And this gets into some pretty complicated questions about the history of fire suppression. in the West that are somewhat beyond the scope of our paper or this presentation. Um, but for the second question here, in a lot of cases, um, vegetation cover does change leading up to fires, um, because more frequent fires would have maintained a mosaic pattern of um, forest with, patches, but also big gaps frequently. But fire suppression over the last century and a half has led to thicker, more homogeneous forest stands that, when they do ignite, burn at higher intensity. Um, and this is what we are grappling with right now in California.